All right, thanks for that, Pierce. So, what we're going to look at is the diagnostic assessment, which has been built on the back of the key knowledge, key skills, and the VCE exam data from the Chemistry 2024 exam. So, what students are going to complete is a three-tier diagnostic quiz before they undertake the practical assessment. So, the three-tier structure is used to assess students' conceptual understanding and their confidence levels. So, it's going to ask them a question, get them to decide on the underlying reason, and then provide a value out of 5 of how confident they are about that concept. Each of the questions have been formulated using the data from the 2024 VCE exam so that we're addressing the specific areas that students found difficult that we're going to be looking at during this practical. Right, and results from the diagnostic assessment will guide our teaching practices during the resources, the student worksheet as well. Okay, so one of the examples we have here, so is in line with the exam data, only about 60% of students were able to correctly answer the half equation question with accurate reasoning. So we have this question here, which looks at half equations. It requires the students to provide their reasoning for the answer that they selected, and then they fill out their confidence rating below. Okay, and the pre-lab questions will emphasize student understanding of half equations and stoichiometry calculations, and specific formative checkpoints will be implemented during the calculation of concentrations, which we'll see when we look at the student resources. All right, so for our second example here, we have based on the exam data, only 15% of students were able to accurately identify resolution. So we've got the question in here that looks at Biuret readings, gets the students to provide their reasoning, and then again provide the confidence. And we've got 12 different questions that look at all of the different concepts that we're looking at during this practical. And we'll use this to address, we will look at accurate Biuret readings. There'll be a focus point during the initial demonstration and within the pre-lab questions as well. So we'll really make sure that students know what they're looking for when they're doing the practical. We'll use peer assessment and micro check-ins that will be used during the titration stage of the practical. Okay, so explaining supporting worksheets for developing conceptual change. So the targeting areas of student difficulty identified in the 2024 VCAA chemistry examination report will guide the questions that we use within the worksheet. The pre-lab has been designed to link the domain of observables to the domain of ideas, so basically what the student's going to be seeing to the underlying chemistry that's actually being explored, which a lot of students do have trouble with. We're going to address and build awareness of instrument precision, and that will occur during the pre-lab. And we're going to connect the doing to the learning, so making sure that students have things to do throughout the experiment to make sure that they're bringing the attention back to what is actually occurring on the microscopic level. We're going to have step-by-step calculations to improve calculation accuracy, so breaking down all the individual steps. And finally, we'll have real-world application during the discussion section of the worksheet to ensure that students are seeing how this chemistry can actually be applied in the real world and making that connection there. So the supporting worksheet as an assessment tool. So one of the first things that we see from the VCAA data is that students have weakness in balancing redox half equations. So we've included these questions in our pre-lab. So what is the oxidation half equation for ascorbic acid in the titration, the half equation for iodine, and what is the stoichiometric ratio between ascorbic acid and iodine in the titration reaction. Right, and this will allow for us to assess conceptual understanding of redox reactions before students actually complete the experiment and they're deep in the experiment, so that we can address any misconceptions and make sure they're on the right path. They're able to relate the chemistry to what they're seeing. Second one here, so many students lack fluency in conventions of laboratory precision and struggle with the ability to evaluate error and validity. So the pre-lab questions offer an opportunity to address the importance of accuracy, and we've included a question on the Biuret volumes and how this will affect future calculations. And here we just have a little photo from a class that Pierce sat in, where the teacher in charge was demonstrating how to read a Biuret and how important that is going to be to their calculations. One persistent challenge identified by the examiners was student difficulty with stoichiometry, with many students failing to apply mole ratios correctly in calculation questions. So obviously as I said earlier, we've laid that out in specific questions so that we can see how students are getting to their answers, and which allows us to see many different or provides many different opportunities for us to see where students are going wrong and provide intervention where necessary. And the last, so when we looking at the real world connections, students often struggle to apply chemical calculations to unfamiliar real world context. So the discussion question that we've included offers an opportunity to assess conceptual transfer to a real world scenario where students are asked to look at how vitamin C concentrations can be affected by different factors, and whether this would influence the selection of fresh fruits or different types of products that are available to them. And here we have the question there for you to look over.